Paper 1. I'm going to be doing part 4 of 11.4 Graphic Solutions of Linear Equations. Today's the final lesson in this section, and it's actually going to be just a wrap-up lesson and kind of going over everything we've done before. We're going to look down at the principles for this lesson and the example that they gave here, and then we're going to look at one of the questions from your classwork, and that'll be it for this lesson. If you haven't watched the previous lessons, you should probably go back and watch those first, otherwise you won't really understand a lot of what we're doing here. Alright, so let's look at the principles for 11.4. There's only 3 principles, and these are probably ones you want to write down in your journal so that you can remember these. A single linear equation involves 2 unknown numbers is indeterminate. 2 linear equations involving 2 unknown numbers are determinate, provided the equations are independent and form a system. They are satisfied by one and only one pair of common values. The pair of common values is represented graphically by the coordinates of the intersection of their graphs. So let's take a look at the example they give us here. So they want us to solve graphically the equation 4y minus 3x equals 6 and 2x plus 3y equals 12. Well, there isn't really a way to reduce any of these down quite as nicely as we would normally like to do as we did in yesterday's lesson. So we're going to figure out what x and y would equal if they had certain values. Alright, so if x was 6, and let's plug that in here. So 4y minus 3 times 6 equals 6. So 3 times 6 is 23. So the easiest way to do that is then to add 23 to both sides. I'm actually going to move the equation down here so we can see it a bit better. We're going to add 23 to both sides. So that leaves us with 4y equals 29. So then we divide both sides by 4. The y's cancel out, or the 4's cancel out, and y equals 6. So if x equals 6, y equals 6 for this equation. And now let's see about the other equation. If x equals 6, so 2x plus 3y equals 12. 2 times 6 plus 3y. That's a horrible looking 12. So this is going to be 12 plus 3y equals 12. Subtract 12 from both sides. You end up with 3y equals 0. Divide 3 by both sides. You get y equals 0. And we can see the proof of that in our plots, where you go 6 to 6 and 6, 0. There's 2 of our plot points here. Now, there is times where we may have ones that don't fall on an even number or on a whole number. Is a better way of phrasing it. On those times we're going to have to use point something and not use the full. So for this one, if x equals 0, what does y equal? And then in the same here, if x equals 0, what does y equal? So 2 times 0 plus 3y equals 12. That's going to be just 0. Which means we can just automatically go ahead and divide both sides by 3 and end up with 4. And for our next one, 4y minus 3. Again, we end up with 4y minus 0. So go ahead and divide both sides by 4. So 4 goes into 6 how many times? Well, it's going to be a point, isn't it? And then we're going to have a point and bring a 0 down. And 4 goes into 20 5 times. So y is going to equal 1.5. So in this instance, if x equals 0, then y is going to equal 1.5. X is 0, will be 1.5, and then 0, 4. So we're already starting to see that we can already see the graphs because they've already done it for us, and we can tell that that's, if we really look at this point, it's not fully on a whole number. So we can tell already that the point that these two lines join at is going to be a decimal point. And we can't really see what decimal point it is, so for ones like this, you kind of have to get as close as you can. So you may try 2 and see what happens, and you may try 1 and see what happens, and realize that it's somewhere in between those two. And from there, start working your way. Probably you can just start working 1.1, 1.2, 1.3, or since how you can tell it's closer to the 2 side, maybe 1.9, and then work backwards 1.8, and see what happens with each number as you work it. Now we have a small advantage here, as the book has already told us that to the nearest 10th x is going to equal 1.8 and y equals 2.8. So we can already tell that that's what p is going to be and where they're going to overlap right there. So we can tell that for both of them, we need 1.8 to 2.8 and 1.8 to 2.8. But like I said, when you're first trying, if you just start at your whole number and kind of work your way down the point system, it's going to be to the nearest 10th, so it'll be easier for you to do it that way. And then when you remember, you got to test it. So if we say 4 times 2.8 minus 3 times 1.8 equals 6. So then you're going to just multiply both of those numbers together. Alright, so we can tell when we check this, we go 4 times 2.8 is 11.2 minus 3 times 1.8, which is 5.4, equals 6, and then we can stack these to make it easier to subtract. So we have 11.2 minus 5.4, which is actually going to get to 5.8, but then when we round up, it does equal 6, so both sides will equal 6. And then we can test it with our other one as well, of 2x plus, let's just go ahead and plug it in, make life easier. 2 times 1.8 plus 3 times 2.8 is going to equal 12. So we have 2 times 1.8 equals 3.6 plus 3 times 2.8 equals 8.4 equals 12, and then again I find stacking it to be easiest to do, but if you're more comfortable doing it long-wise, that's fine. It's just personal preference. So 6 plus 4 is going to be 10. Secure your 1, put down your 0, 8, 9, 10, 8, 9, 10, 11, 12, and this comes out to 12 even. And that's our example, and we have proof that it does work. Alright, we're going to do question 19 together, just so that you can, just to give you one question that we are doing together. Alright, so we have 4x minus 10y equals 0, and 2x plus y equals 12. Now let's look at these. Is there any way we can reduce one of these questions down so that it makes it easier to solve? We could times or divide both sides of this one by 2 and make it 2x minus 5y equals 0, as that then makes it slightly easier to deal with because the numbers aren't quite as big. And then this one we can't really do anything with, so we'll just leave it as is. Alright, let's try a nice low number. Let's go with 0 for our first one, because that's simple and easy to do. So 2 times 0 is going to be 0, so 0 plus what equals 12? 0 plus 12, 0 plus 12 equals 12, and then 2 times 0 is 0, minus 5y to equal 0 is going to be, it would have to equal 0 in order to times it by 5 to get 0 as well, so 0 minus 0 equals 0. So now let's plot our points. So we have 0 and 0, and we have 0 and 12, which really isn't on our chart, so we're going to say 9, 10, 11, it's going to go up here, 12. Kind of off our chart a little bit, but that's okay. Alright, well, let's try to stay on the chart this time. So we know that 0 took us way off. Let's do a big number on the other end of the spectrum to see where our lines might end up. And this time we want to, again, try to stay on the chart. So let's do 10, because 10 is easy. Alright, so now let's look at this. So 2 times 10 plus what equals 12. So 2 times 10 is going to be 20 plus what is going to get me 12? Well, we already know it's going to have to be a negative number. So what negative number is going to get us to 12? Negative 8. So 20 plus negative 8 equals 12. And both of those are nicely on our chart, so our plan to try to stay on here worked. So 4 times 10 minus 10 times something is going to get us 0. So 4 times 10 is 40 minus 10 times something to get us 0. Well, we need to make 10y equal 40 in order to make it 0, right? So 10 times what's going to equal 40? 4. So y is going to equal 4 on this end. So now we have 10 and 4, and 10 and negative 8. So I can already tell our lines are going to go into some funky directions here. Alright, let's try to do one to keep it on the chart, but that's kind of an in-between point to give us a third point to bounce off of. So, well, let's go right in the middle here. Let's do 5. We'll do 5 for both of them. So, 2 times 5 plus what equals 12. Well, 2 times 5 is 10, plus y equals 12, which means y has to be 2. That's 10 plus 2 equals 12. And now 4 times 5 minus 10 times something is going to equal 0. 4 times 5 is 20. Minus 10 times something equals 0. So 10 times what's going to equal 20 in order to make it 0? 2 as well. So y over here is also going to equal 20, which means we have our intersection, which makes life a little bit easier now. So now we just connect our dots. With our very big lines. And this isn't going to connect very evenly because my 12 had to go off the chart a little bit here. So, alright. And remember to your equations so that you know which one is which. So this one, and remember we're going to label it with their original one, not the one we changed it to. So that's basically what you're going to do for your assignments today. So for classwork, you have 15, 17, and 19, which we just did. And for homework, you have 16, 20, and 22. And that's the end of 11.4. Again, if you haven't seen the previous ones, you should probably go watch them. I'll put the link in the top for you. And yeah, thank you, like and subscribe in order to see more math content, and I'll see you next time.